Galloway's presents Tech Talk at 3 with Dr. Simone Stumpf from the Orbit Project.
Good afternoon and welcome to Tech Talk at 3. It's Andrew here, Assistive Technology Coordinator at Galloway's, and I'm really pleased to be joined by Dr. Simone Stumpf from the University of London. Hello.
Hello.
How
Hello.
are you?
Welcome,
How are you
everyone.
doing?
Yeah, fine.
But it's great. It's great to have you on here. And Tech Talk at 3. We love technology, obviously, but we love AI. We love artificial intelligence, and we're big lovers of apps like Seeing AI and Be My Eyes, and lots of different apps that support blind and partially sighted people. Obviously, it's great to have you on today to talk to us about the Orbit project. Which I heard about on the RNIB Tech Talk show. So it's great to have you on board, and I think over to you, Simone.
All right. Thank you very much, Andrew. So I'm going to share some slides, and I'm not expecting anyone to read them. They're more for me.
Yeah.
Okay, perfect. Right. So hi, everyone. So my name is Simone Stumpf. I'm a senior lecturer at City University of London, and what I'm interested in particular is accessibility and also AI, and in this project the two really combine. So I wanted to give you an overview of what the project is about, what we're actually doing, what AI is capable of, and then also give you an update of how far we've got and what we're doing next. So if you're interested, you can send me an email at simone.stumpf.1@city.ac.uk, and I spell that for you. It's simone.stumpf.1@city.ac.uk. I'm also on Twitter. I'm not too sure if anybody else is on Twitter. There I'm at Dr. Simone Stumpf, all one word. If you want to follow me, we also have a project website, which is orbit_project. So you can find us there. Let me tell you a little bit about our team. So this project has a large number of people working on it. So at City University, we have a researcher called Lida, and she is responsible for running the show from day to day. And we also have Toby Harris, who's a developer. So he programmed the app that I'm going to be talking about in a little bit. And then we're also working really, really closely with Microsoft Research. So we're working there with Cecily Morrison, Ed Cottrell, Katja Hoffman, and Daniele Massicetti. They have a variety of backgrounds. So Katja and Daniela come from a AI background, and Cecily and Ed come more from a accessibility background. And then we also have a PhD student at University of Oxford, Louisa Zingraf, who's also coming from an AI background. So we have quite a lot of people involved in this project. So it's not just me, and a lot of thanks goes to them because we work really, really closely on getting this project done. Okay. Before I tell you a little bit about what the project actually does, I need to set the scene a little bit about which area of AI we are talking about, right? Because AI is huge, right? And what we are dealing with is what is called object recognition that relies on computer vision technology. So it's essentially the computer seeing something or identifying something, and then using algorithms, AI algorithms, to identify what that object is, and then you can use that in applications. So that is the area that we're dealing with. So recognizing objects by the computer. And the way that that usually works is that these algorithms that detect or recognize objects are built on data sets. And these data sets are huge. So ImageNet, which is used by a lot of algorithms to develop these computer vision algorithms, that contains over 14 million pictures. Right, so and those pictures are contributed mainly by sighted people. So they might submit 1 or 2 pictures, or you have some super users, as we usually call them, or super contributors, who take hundreds of pictures, right, of objects. And they get stored in this database. They're labeled. So the image says, okay, this is an image of a cup, right? And then a computer algorithm can be developed that recognizes cups or whatever is in that database, right? And once these algorithms are developed, you can build them into apps like Seeing AI, right? And I don't know, I think Andrew said earlier that a few of you might use Seeing AI, right? Give us a quick wave in front of the camera if you use Seeing AI. Yeah, perfect. All right, I can see a few waving hands there. So that is great. If you're not using Seeing AI, then let me just try and give you a quick demo on my phone. So you have it on your iPhone. It's an app called Seeing AI. You can download it. And let me switch voiceover on.
Image is visible.
Right. Okay. I'm back in.
Bottom and left edge is not visible.
Right. I'm back in Seeing AI. And there's a little tab in there which is called Scene. It's in a sort of developmental stage. And what happens is if I point it at something random, I'm going to take a picture of my glasses. Let's see what it does with that. On a desk. So I'm taking a picture now.
A pair of glasses on a table.
And so it successfully recognized that it's a pair of glasses on a table, right? So this is great. It's really, really useful for people. You might think, great, so what is the problem here? And the problem here is that object recognition at the moment can't actually recognize objects that are not very common in data sets. So if you remember, in the 14 million or over 14 million pictures that might be in ImageNet, they are collected by sighted users. So they're not going to have either any or very many examples of, say, white canes in there, or braille readers, or anything like that that might be particularly interesting to blind and low vision people, right? So anything that isn't very common in those data sets is bound not to be recognized. And the other thing that this kind of object recognition can't do is that it can't tell you whether an item that you're taking a picture of is yours or someone else's, right? So if you take a picture of a bunch of keys, it will tell you, well, those are keys, but it won't be able to tell you whether those are your keys or your partner's keys or anybody else's keys, right? So it can't tell these different items apart. One of the things is that, and that is where we're focusing our project at, is that we are working in what is called personalized object recognition. So the way that would work is that you register your item by teaching the AI using a few examples of what it looks like, right? So it can recognize that this is what your sunglasses look like, or your set of keys look like. And then in everyday use, you would use that AI program that, you know, a little bit like seeing AI, to find or identify an item as yours. So it will be able to say, yes, those are Andrew's keys, or those are Simone's sunglasses, right? That is really what we're interested in, to do personalized object recognition. But that leads us to yet another problem, and that is that we don't actually have any data to develop personalized object recognizers for people who are blind or low vision. So this doesn't exist, and all AI needs data, preferably lots of data, to learn how to work, right? So for an object recognizer, you need lots of data to recognize objects. For a personal object recognizer, you need, you know, also lots of your data to recognize your items. The reason that we really need this data set to make progress in this area is that we need to involve people who are blind and low vision in capturing that data or collecting that data for us, because it's no good going to sighted users who will just take the same pictures like they always do, and so they will never include white canes or anything like that. And also we need to develop something that is useful for blind and low vision people. So if we're asking you to take a picture to register your item, then that needs to be usable by people who are blind and low vision, right? It's no good explaining it in a way that sighted users could use. What we also need to do is really develop better algorithms that recognize what an item looks like, or what an object looks like, from just a few pieces of data. So usually in object recognition, you know, that database of 14 million pictures per object, you usually would have hundreds of different pictures to be able to recognize it. And if you think about it, like if you want to register your personal item, you're not going to take hundreds of different pictures of your sunglasses. You want to just perhaps take 5 or 10 pictures of your sunglasses, and then that needs to do, right? So we need much better algorithms that are capable of learning from just a few pieces of data. These this data, these pictures from for example, need to be really good enough quality to teach an AI. So one of the things that we obviously need are pictures where the object is mainly in frame, right? You know, we don't need it to be perfect, but we need it to be good enough quality. Until this project, we also weren't too sure if we could get the quality that we need for, you know, developing that AI. And what we also need is include sort of realistic examples of trying to find items. So how would that be used in a real you know, in real life once we have developed these algorithms, because we don't not only need to train or teach these machines how to recognize items, we also need to figure out how good they are. And for that, we need to have what are called testing data, right? So it needs to sort of show almost a sort of realistic scenario of you trying to recognize or identify an item that you have just taught the system to recognize. Okay, so there's really a lot of technical challenges in there, but also what is really interesting is that there are a lot of what I call user challenges in there, right? So, and that I think will become a little bit more obvious when we go through the rest of our talk, and I'm sure you have plenty of questions about it later. So what our project is about is that we want to collect data sets from blind and low vision users. Those data sets will consist of videos, so short videos of objects that you might want to recognize. And then we try them out in a sort of initial testing phase and evaluate how good you know, of an algorithm we can develop based on that data set. And then we want to make these data sets public so other people can also improve on our results. So we want to make it as a general resource to researchers, developers, you know, a broad range of organizations who can then develop their own algorithms as well and build that into applications. So it's really a community resource that we're trying to build. Okay, now one of the things that I said was that we are going to collect data in the form of short videos, right? And we've had plenty of experience, and there's other research around about, you know, for example, how blind and low vision users take photographs. So blind photography is a big thing. And also there's a lot of stuff known about what the challenges are with that, right? And I mean, some of it is relatively obvious about, you know, how to keep stuff in the frame of the picture, how to make sure it's not too blurry, that kind of thing, right? But what we are moving away from, for very good reasons, is that we're not taking pictures, we're taking videos, right? And nobody has actually done any work with videos before, and there's actually not much known about how blind and low vision users take videos, for example. So we had to try out a few things about, you know, how you take good videos, particularly to develop these data sets. And I can talk a little bit more later about that. Okay, so what we have done so far is, so this project has been running since, for about a year now, almost, I think we started end of October last year, so we're nearly a year through. And we've completed phase 1 of our data collection so far. So we finished that, I think, mid-July. We're still analyzing that data. But what we did in there, we gathered over 3,000 videos from nearly 50 users, and they were all based in the UK. And it was really interesting. It taught us a lot about, you know, what kind of object might end up in a data set like that. And there were lots of different objects that people took videos of. The most popular though were white canes, keys, wallets, backpacks, glasses, earphones. But then we had also some really surprising items. So we had at least one face mask in there, which obviously with lockdown was really topical. We also had wheelie bins or wheelie bin in there. We had front door and lots of other really unique items that we could have never predicted. So overall, I think, you know, people really got into, well, what things would I want to recognize? And a lot of them were very, very unique and personal to people, right? So we just finished that. We're analyzing that, as I said. So our AI people are running that through some algorithms, and we're getting encouraging results. There's still plenty of scope for improvement. So at the moment, we're hovering around 50% accuracy. So in a way, that might not sound really, really good. But actually a lot of computer vision is not that accurate. So you have a 50% chance of it getting it right, which is actually not too bad, considering that, you know, it could be any number of items. So we made people gather videos from about 10 objects. So, you know, a 50% chance out of 10 objects is actually not too bad. So we just did that. And then we are about to enter our phase 2 of data collection. That is a global data collection. So it's not just people based in the UK anymore. We're going to issue that or start collecting data from people all over the world, well, at least the English-speaking world, because we can't translate our app into all of the different languages. And what we are asking people to do is to collect 7 videos each for at least 5 objects. So we've come down from the number of objects a little bit, but you know, people should think of about 5 objects that they might want to have recognized at some point. And the 7 videos consist of what we call 2 testing videos and 5 training videos. So I explained to you earlier that we need these sort of realistic scenarios in which you might use this, you know, an app like this. And so what we're asking people to do is provide 2 examples of how they, you know, might try and recognize that in what we call a scene. So in amongst other items, essentially. And then 5 training videos. So 5 videos that show us these objects from different sides, so we can teach the AI program to recognize them when they are encountered in real life, right? So what we have done is we have developed really detailed filming instructions of how to record these videos. So these 2 different types of videos. They're really quite short, so the videos are around 20 seconds long. They don't need to be perfect. And really they're all based on a principle that, at least the training videos, is that we encourage people to use one of their hands as what we call an anchor hand that is placed next to the object. So when you point your smartphone camera towards your hand, right, you have a really good chance of keeping the object in frame, right? So these filming instructions are simple, but incredibly important to get that quality that we need for training AI algorithms. And we'll think it takes about an hour to do. So an hour from reading all of these filming instructions, you know, all of the bump that goes with it, but then also recording these 7 videos per object, and as I said, 5 objects. So we're just about to start that. What we have done associated with that is we have developed what we call the Orbit camera app. That's an iPhone app that allows you to take the videos, right? And it's fully accessible through VoiceOver. It sort of navigates you through. It's a very simple app as well, so there's not much fluff around it, and it really helps you to record these videos and then uploads the data, the videos, while you sleep. So when you're plugged in to power and you're on Wi-Fi, it uploads it to our server. The server is really secure because we obviously don't want any data to leak out. And we also have developed a procedure so that any personally identifiable information, any personal stuff, doesn't get stored on the server. So we weed out any videos where there might be a photo in the background of your kids, or there's an address envelope showing as well. So anything like that, we just throw out, so we don't store it. So we've made the best attempt to keep everything private and confidential. Okay, so that's the camera app that we developed, and as I said, you need an iPhone for that. There's a few other things that we discovered along the way. You have to have enough storage on it, but we worked out a way of deleting videos that we no longer need, so we're not taking up too much storage. But there's a sort of certain minimum requirement that we need on the iPhone that you have. So to take part, we think that we're going to start the data collection on Monday, and we're going to keep that open for about a month. To take part, you need to be over 18, be blind or have low vision. You obviously need an iPhone to participate. So if you have any other brand of mobile phone, I'm afraid you can't participate, because we were only able to develop one version of app and get that really good. And you need to be able to give informed consent. So we provide a lot of information that you need to understand before you need to take part. So if you are interested, you can go onto our project website, that is orbit.city.ac.uk, so orbit.city.ac.uk, or you can email Leader as well, and Leader's email is leader.theodoru.2@city.ac.uk. I'm going to spell that for you. So LIDA.THEODORU.2@city.ac.uk. If you are interested, we haven't quite launched yet, but there's placeholders on that. You can put your name down to participate as well, and then we can email you once it's up and running. But we are looking for more people to help us with the data collection. So it would be really great if you wanted to do that. I have come to the end of my talk. I talked probably a little bit longer than I wanted to, but we still have plenty of time for questions. So
Brilliant. It was excellent. Really good stuff. Very detailed, and obviously there's a lot of work to do, a lot of data to collect obviously to make all this possible. And thank you very much for for going through that with us all. And the just a question for me really. The this data that you collect, the video data and the pictures, does this feed in specifically to Seeing AI, or does it benefit other types of apps or app developers that use AI to for object recognition?
So what we're careful in doing is obviously this is a Microsoft funded project, right? And we have really good links with Seeing AI. We are talking to them. In fact, if you are using Seeing AI, you will see a little pop-up notification soon about the Orbit project.
Okay.
But the thing is that we don't want to make this exclusive to Seeing AI because not everybody has Seeing AI. Other people might use TapTapSee or other apps that are coming on the market. What we didn't want to do is sort of ring fence that just for Microsoft. It should benefit as many people as possible. And it might be that somebody can actually use our data set and come up with something completely different to what we ever imagined somebody doing with that. So for example, we've also been talking to a company called Humanware. Some of you know
Humanware. Yeah.
They are really interested in working with us because one of the things is about navigation, and any sort of app to navigate usually can get you so far, but then the GPS might not be that good, and so it's actually often the last few meters that are the most crucial. And they will say, well, if we could have someone train this app with the front door of my friend's place, then the app would have actually a much easier time to navigate to that friend's place, right? So they actually looked at this more like how can we use this data set for navigation rather than for personalized object recognition. So people might actually come up with really, really innovative ideas.
Yeah, because you could use it to recognize areas of building and then feed that data set into an app. So then when you're walking around the building, it would recognize potentially where you are, or that's really, really interesting. You mentioned TapTapSee. TapTapSee is a real kind of, for me, is a real legacy. It's got a real legacy to it because it's been going for such a long time. It's kind of one of the first apps that I remember using for object recognition. It was like, wow, I think that was back in like 2012, 2013. TapTapSee is a brilliant app. So we've definitely come a long way. It's quite interesting, I suppose, the video side of things, people filming videos. Is that also to gauge how people hold their phone and how they recognize that object, the different angles they might be pointing the phone at and stuff like that? Because it is difficult for people that can't see to use apps to recognize objects, because sometimes there is a certain knack to it or a technique to get in the right position with your phone, and like you were saying with your hand. I like the way you described, if you point the phone at your hand and you touch the item, or you put your hand near the item, you've got a good opportunity. But is there a reason what's the reason behind the video kind of capture? Does that help you get more data than pictures? You can probably get hundreds of pictures from a video, can't you?
Yeah, exactly. So Andrew, you hit the nail on the head. Basically, I mean, if you think about it, an iPhone takes 30 frames per second, right? So that means 30 pictures per second. right? So if we're saying, okay, let's shoot a 20-second video, right? You have 600 images or 600 pictures that you can use, right? So the reason that we switched to videos is it's really, you know, a lot more data that we can use. And also, we think actually it might be easier for the user because at least at some point during the 20 videos, we are bound to have a good image in there.
Yeah.
Right. So you don't have to be as careful as with a photo where you have to have everything kind of perfect, you know. Whereas a video, you can wobble a little bit, you know, it doesn't have to be in frame all the time. So, you know, it's much more forgiving, actually.
Yeah, it's good. It's a good point. It's like if you take a picture, I always say take it 5 or 10 times so you get the right, so you can pick the right one. But whereas on a video, you're right, you can get so much from the iPhone. And some iPhones, I think, will do 60 frames per second as well. So you get 60 pictures instead of 30. So yeah, brilliant stuff. And I think what we'll do as well, you know, to help people get involved, we'll get some information to people on our mailing list and on our social media. If you can send it through to me, and we can share the email and the web link and stuff like that as well.
Absolutely. There's a sort of question from Tracy in the chat about are there any future plans for you to extend this onto the Android phone? And we thought really long and hard, and we're still trying to do that. It's just that in the time we had to get everything really good, we wanted to concentrate on iPhone first, but we've have some plans in place to get this done for the Android. So in future data collection, we hope to have an Android app that people can use.
Right.
And for those Android users that use Android, we've all heard of the rumours of seeing AIs eventually is actually going to come to Android. There's strong rumours about that. So all this kind of data set that you've been collecting will eventually, or could eventually at some point, benefit people on Android anyway. Especially if seeing AI comes out.
Yeah. I think, you know, I don't want to say the problem with Android, but there's so many different flavors of Android and so many different camera specifications on Android platforms, and it just gets really difficult to develop something that is.
It's a really good point. You
can
narrow it down. You can narrow it down more, can't you, with the iPhones? Because you know what, you know how the camera app works. You know what the permissions are in terms of what access you've got to the camera from the app and all those types of things. So yeah, it probably is a lot easier using that side of things. Absolutely brilliant. I think we'll open the floor and to everybody, and we'll unmute you. You should get a message on your screen that says the host would like you to unmute. You can you can stay muted if you so wish. We won't be offended. Or you can unmute yourself, and you can pick the unmute button, and then you can ask us a question if you want to go ahead and ask Simone a question. Have we got any questions? We normally have.
Hello, Simone. It's David Hughes.
Hi, David.
Yes, quite apart from being severely sight impaired, I lack manual dexterity through long-term rheumatoid arthritis, and I wonder if I could easily participate in the project, basically.
So in terms of the targets, for example, the controls for recording videos, they are all gesture-based, which should be available to you. So all it is, it's probably a bit of swiping. And then we made obviously the controls like the record button and the target area to hit to start off a video really big. So you know it should work for people who have some kind of dexterity problems as well. So hopefully that shouldn't be a barrier to you.
Thank you.
Really good question, actually. Very good question. Okay. Have we got anybody else that wants to ask a question?
Can I ask one, Andrew?
Yeah, go for it. Go for it, Stuart.
You mentioned at the beginning that this would be useful for people recognizing whether objects were their own objects. So are you anticipating that Seeing AI will have a feature where you can take pictures of your own objects?
Yeah, so eventually what we're hoping is that, Seeing AI might use it, and there might be a feature in there where, you take a picture of your own objects. So it could be anything that you might want to recognize, that is especially important to you, that perhaps gets moved around accidentally by other people, or that you misplace, or we've heard quite a lot when people meet, obviously not during the pandemic, things just get mixed up, right? Figuring out quickly which coat is yours or which white cane is yours, that kind of thing. So you could actually have a feature in that app where you take pictures of that, teach the algorithm to recognize what's yours, and then when you're out and about, you can just point the phone at something, like a corner of the room, and it would tell you, oh yes, your coat is over there, right?
Yeah, because you can use Seeing AI. I mean, the facial recognition is also quite experimental in Seeing AI, and you can actually save people's faces within Seeing AI as well. So yeah, I mean, I think that would be a really good thing to be able to do. Like you say, recognizing your own devices. Absolutely, and especially like, I don't know, sometimes like if you lose something in the house and you're trying to find it, you might not even have the device to hand, but you might be just kind of moving around with the camera trying to find where it is in the house, and if possibly it can, pick it up, possibly at the same time, maybe. Yeah, I mean, I think that would work really well.
Yeah, I think it's really one of the challenges that we have in the project is we're trying a little bit to predict the future and how people are going to use that, or what it might be useful for, or what this app, is going to look like in a year's time that we haven't developed yet. So it's really blue sky stuff, where we just don't know. We're just guessing at things. But we know that, object recognition is really useful. Facial recognition is really useful. So, I think this has the potential to be really useful to a lot of people.
I think as well, with a lot of kind of products like food products and things like that, we're seeing AI. We can scan a barcode at the moment, and sometimes if it's from like a Tesco or an Asda or somewhere like that, it will generally get the barcode. If it's from like an Aldi or a Lidl, sometimes it doesn't get the barcode of what it is, unless it's depending on what the brand of the product might be. So then you kind of then will revert to using text recognition to maybe recognize the text of the product, but it doesn't get the branding or the logo of the product. So it's sometimes quite difficult, and that would be an area of interest for me as well, whether we can at some point, get data sets out there that where companies actually, they get involved in this research and they create data sets for their products, so that when somebody uses an app like Seeing AI, they can I've just picked up Kellogg's cornflakes, and rather than having to scan the barcode on the box, it gets it from the data set and it knows it's Kellogg's cornflakes. And I hope one day we can get more to that. And there are some apps that can do it, but you have to create your own data set within the app, if you like, take your own pictures and then tell it what that object is. But that's also an area of interest for me as well.
Yeah, I think I think it's really interesting to imagine how this might be used. So we know that people tend to be very organized and very meticulous in where they put things, and this will actually be really, really useful if somebody has moved something, or if it's in an unexpected place, or almost you don't have to be as organized as you previously were, because something like that can actually help you.
Yeah, absolutely. Some interesting comments coming through on the chat here. So just while we're on, we were talking about the products. We've also, Denise has said that it would be really good if an app could tell you if a food was okay to eat. For example, if the bread was the quality, if the bread was moldy or not. I mean, I have actually used apps like Be My Eyes in the past to ask that particular question. Does this bread look safe to eat, and whatever. So basically, what we're going to have to do, guys, is before you throw that moldy loaf out, start taking loads of pictures of it and send it to Simone, so he can create those data sets. But I think that is another thing. There's lots of learning, lots of different ways that blind and partially sighted people want to use image recognition for. If they can't speak to a human being to give them that answer, AI could play that part. Does this bread look moldy? Is what's the sell by date on the milk, for example? If you can't find the barcode, because that's a difficult thing to find a barcode sometimes. But do the strawberries look moldy? I don't know. That type of thing.
Yeah, I think we're just really fascinated also by sort of different kind of objects that people have contributed in the first phase.
Yeah.
Some of them we were really surprised by. We had some funny incidents about people asking us if it's okay to take certain, take videos of certain objects.
Okay.
So all I want to say here is that if you own a dog, picking up after the dog is really important.
Okay.
We had a question about that. I'm also just, I think Tracy in the chat is saying, well, we could take pictures of fresh and moldy bread. I think that is a great idea. That's actually a really good approach. I think Key had a question about the.
Yeah, I was going to come back to that. I knew that one was first. I was going to come back to it because we were talking about the recognition. But yeah, you're right. So the actual camera app, what version of iOS, Apple's operating system, can you run the app on, and can all the which iPhones as well?
Yeah, so it's kind of any iPhone running iOS 13.2 or higher.
Oh, okay.
That's can't remember what we're on at the moment.
14
I'm
now.
going to have to leave you now, ladies and gentlemen.
Thanks, Ted.
Right.
All right.
That's last year's. That's last year's iPhone. That's September 2019 is 13, and now we got 14's just come out.
Yeah.
So most people, I suppose, with an iPhone of 4 or 5 years old, will at least be able to have got to iOS 13.
Yeah. So that it's really, in terms of the iPhone age, it's not so much that. It's more about the operating system, because they have changed certain things around which we are relying on, and the other thing is storage. So we have to have a certain amount of storage that you have, just because of the size of the video. So we
something like an iPhone 8. I mean, would that be
sorry,
an iPhone 8? Would that be too old? An iPhone 8?
No, I've got an iPhone 8. So
oh wow, there you go. Fine.
And
Okay.
that works. That's cool.
Yeah.
That's cool. Excellent. Have we got any? We'll take one more question for Simone. Oh, I think one's coming. We'll take one more text question and one more audio question. So let's have a little look here. The texts are going well. Okay, so question, taking reading of a digital LCD or LED display, read by seeing AI. Oh, can it be read by seeing AI? I think it can. Yeah, I think you can take pictures of digital displays. I've even used seeing AI to read stuff off the television screen, like what programs are on and things like that. So yeah, you can do that with a text recognition, but obviously this is more, well, it's object recognition, I suppose, isn't it?
Yeah.
So.
I mean, object recognition and also in our project, you only really have to be wary of things that have a high glare, so they're very shiny and very glossy. Then you can, the algorithms don't work very well, but LCD or LED display should actually be fine, right?
Cool. Okay. Have we got anyone else want to ask an audio question?
Do you have different voices? Are there different voice options for people, like male, female, that sort of thing?
Oh, so you can switch on voiceover, and then it's just the voiceover.
Oh, right. It uses the voiceover voice. Right. Okay.
Okay, brilliant. Okay, excellent stuff. Okay.
What about?
Go for it, John.
What about when you get photos or videos on a WhatsApp group? Would you be able to get that to the CNI to tell you what's on the pictures on the WhatsApp or the videos on a WhatsApp group or any other social media?
That's a really good question, actually. Or you might have an answer to that one, Simone. I've got one as well, but you might have one also.
So in terms of object recognition,
well, yeah, because like with me, people send the photos, and only if they put something to describe, then I'll know. And they don't even fully describe them because they're leaving out all bits of information at times, or even in the videos.
I hear you, John. I hear you, mate. I really do hear you. It's something that I struggle with as well. And I'm always messaging people back going, what's that picture you just said? Well, it's Thingy Me Bob. How don't you know who that is? And they say, I'm blind, I can't see, and obvious pictures to fully sighted people are not obvious to us, and sometimes it's a little bit embarrassing when you have to say,
and also
just describe that picture for me.
When they do describe it, they're not fully describing what needs to be told to you.
Yeah, I think, for a still picture, I would actually try seeing AI and see what it does for a still picture. It might actually recognize the object. For videos, that's probably a bit trickier because I don't know many apps that will analyze objects in videos. So
no, I don't either.
As the objects go by, they announce what's in there. But that would be great, right? That would be a really, really cool thing to do.
So I do know I can feed in that within iOS 14 now, Apple have introduced picture recognition via apps and via messages. Basically when you hover or your voiceover, once it focuses on an image, you'll get this beep from your iPhone. It'll go beep, and then it will actually attempt to describe to you what's in the picture using AI. And that's a new feature, an accessibility voiceover feature of iOS 14, which is available on all the new iPhones and all previous generations if you can upgrade. And it works through Facebook as well. It works on WhatsApp. So you get a picture and you navigate and it goes beep and it starts. It doesn't really tell you that it's identifying the picture, but it analyzes it in real time because you've focused voiceover on it, and then it speaks back to you. So it might basically, I've had pictures that have come on to my iPhone, and it'll basically say something like person standing in front of a house, or so it can't give you a relative description as it knows exactly what the picture is, but it can look at the different images and objects and give you an idea of what is in that picture. So it's not going to tell you, for example, John, that that Jurgen Klopp's in the picture, but it might say a man with glasses and a beard, basically, and that's generally how it works. So you can do it in iOS 14, and like you say, all this type of object recognition and picture recognition, it's all feeding into the same outlook, isn't it, Simone? That that you're looking at, really.
Yeah, which is just making things as easy as possible, really. Without having, as you say, people are really not good at providing picture descriptions, and so actually using something that does it for you is really where the future is at.
Yeah. And I think
they'll be doing videos.
Yeah.
I think it's great that Microsoft are recognizing that, Apple are recognizing that, and that we've got projects such as the Orbit project, which is is trying to make things more accessible and more innovative for people that people that are facing sight loss or that have been blind all their life, and that are now starting to realize the benefits of technology and how it can help and support people. And you're right, we Stuart, who is one of our volunteers who's on today, did a great piece for us about AI and the fact that AI is only as good as the information you feed into it. The computers aren't really that clever. It's all about the information we give to that software or that data processing to make it do its thing, isn't it?
Yeah. Absolutely.
It's Kay. Can I ask Simone a question?
Yeah, go for it, Kay. Yeah.
Simone, you've been running the project for a year, you said. How long do you envisage that the project will continue for?
Oh, great question.
So we have another half a year left. We're going to finish 30th of April. That's the current kind of running of the project. We're hoping to get some more funding to continue going with research. But our funding just runs out at the end of April. But we're hoping to release the first slice of that open data set by the end of this month. So that will already go out there, and then for the phase 2 data should be released in January. So we're actually hoping to start seeing some kind of integration into applications really, really soon. So perhaps even sort of early next year if everything goes well.
You could definitely open up a can of beans, if you like. This type of research project opens up more doors for other research projects, doesn't it? Within AI. So it could be a real game changer in terms of how things develop. So absolutely brilliant. And thank you very much, Simone, for joining us today on Tech Talk at 3. It's been an absolute pleasure having you join us. It's been really, really interesting. And we'd love to get you on again, maybe next year, to kind of come and feedback to us how you've been getting on.
Yeah, love to, and I'll make sure I get those details over to you, so people who are interested can actually help us, and hopefully we'll launch that next week. It's open for a month, so you can actually contribute and help us with this project.
Brilliant. And just give us one more time, just give us the website if people want to go on the website. to
Okay,
access.
so that is orbit.city.ac.uk. That's orbit.city.ac.uk.
Brilliant, absolutely fantastic. So there you go, Dr. Simone Stumpf from the University of London and the Orbit Project. Thank you very much.
Thank you very much, Simone.
Thank you, Simone.
Thank you.
That
Very
was lovely.
interesting. Thank you very much.
Bye.
You're free to go if you need to, if you'd like to.
Bye.
You're free to go. I'm going to stay on for a bit, but you're free to go if you'd like to.
Have to
Because I
leave
know
now,
you're a busy
Andrew,
person.
so I'll catch
Thank you very much.